Okay, so today what we're going to be doing is graphing exponential functions. So what you need right now is your graphing calculator. So if you don't have your graphing calculator, you need to put me on pause right now and go get it. Okay, so hopefully you have your graphing calculator in front of you. So what we're going to do first is we are going to complete this chart over here. All right, so I want you to, in your calculator, you're going to graph f of x, which is y equals 2 to the x power. So put that in your calculator. Go to your table of values. And you're going to fill in your y values for f of x. So these are your x values. Your x values are from -1 to +2, and we need our y values. So our y value for -2 is 0.25. For -1 is 0.5. For 0, it's 1. For 1, it's 2. And for 2, it's 4. Okay, so go back into your y equals, clear that out. And now you're going to type in y equals 3 to the x power. Go to your table. And when x is -2, your y value is 0.1. And it's actually 0.1 repeating. And when x is -1, it's 0.3 repeating. And then 0 is 1. 1 is 3. And 2 is 9. Okay, and again, you're going to do the same thing for h of x is equal to 4 to the x power. So type that into y equals. Go to your table values. When x is -2, y is 0.0625. When x is -1, y is 0.25. When x is 0, y is 1. When x is 1, y is 4. And when x is 2, y is equal to 16. Okay, so now let's look at the next thing. It says, is there ever any value of x that will make f of x, g of x, h of x equal to 0? Meaning, is there ever a time when your y value, right, because remember, these are your y values, or is there ever a time when your y value is equal to 0? So you can go back into your table of values and look, scroll, right? Because look, these up here are getting close. These up here are getting close to 0. So if I go to -3, does that give me 0? -4, does it give me 0? -5, does it give me 0? Does it ever reach 0? And the answer to that, so if you need to take a look, take a look. But the answer to that is no. And look at the next one. So if you're in your table of values, is there ever any value that will make, for x, that will make your y values a negative? No, there is no x value that'll make a y value equal to a negative. All right, so the next thing I want you to do is to graph all three functions. All right, so start with f of x when x is -2. Your graph should look better than mine because I am using my iPad and it's harder to write on iPad. So please just be careful when you're graphing. All right, so when x is -2, I have 0.25, so it's really, really, really close to the x-axis. -1 is 0.5, that's halfway. 0 is 1. 1 is 2. 2 is 4. And if we kept going, 3 would actually be 8, so it'll look like this. So that's f of x. Okay, now I want you to graph g of x. So -2 would be 0.1 repeating. So that's really close to the x-axis. Then I have 0.3. So it's a little bit below the red curve right now. And then I have 0, 1, same place as before. And then I have 1, 3. And then 2, 9. Oops, that's the wrong place. That's not 9, that's 7. 2, 9 is up here. Okay, so graph that. So that is g of x. And then we need h of x, so graph that. So that's really close to the x-axis. But then I'm at 0, 1 again. And then I have 1, 4. And then I have 216, which is up here. And that's h of x. Okay, so let's look at the next thing. So I graphed all of them. What is true about all three graphs? So let's see. One thing would be they're all increasing. Right? Another one would be they all go through the point. So all three go through the point 0, 1. Okay? So let's now, down at the bottom, we have to find, it says the domain, the range, your asymptote. Now, we didn't talk about asymptote, so we'll talk about that in a minute. And what increasing, decreasing, and what effect does it have when we change the base. Okay, so I'm going to attempt to move everything up and keep it in place. So just bear with me. Okay, so let's start with the domain. Remember, your domain are your x values. So my graph just keeps going to the left on my x-axis, and it just keeps going up, which means it keeps going to the right because it goes up and it keeps going out, and it goes down and it keeps going down like this. So that means my domain would be all real numbers, and that's actually for all of them because they all look the same. So my domain is all real numbers. All right, now let's talk about the range. Your range are your y values. So my y values are your up-down values. So notice my graph does not go past the x-axis. So it's actually from the x-axis above the x-axis. So that would mean my range, my y values are greater than what number? They are greater than 0 for each one of them. So this would be y is greater than 0, y is greater than 0, y is greater than 0. Okay, so now let's talk about the asymptote. That word right there, vocabulary word, asymptote. Asymptote means it's the line that the graph gets closer and closer to, but will never ever cross it. Okay, so I'll say that again. An asymptote, so let's actually write this down. Let's put it up here. Okay, so write it someplace, maybe on the side of your paper, but I'm going to write it up here. All right, so maybe on the side over here, you guys can write it. So an asymptote is the line the graph gets closer and closer to, but will never cross or touch it. So if you look in your table of values at any one of those graphs and you keep looking for where your y value is equal to 0, it doesn't. It just gets closer and closer to. The number gets smaller and smaller and smaller and smaller, but it never ever reaches 0. Okay, so which is the line, what's the asymptote? The line that this graph gets closer and closer to. So this graph gets closer and closer to the x-axis, but it will never ever cross the x-axis. It just gets smaller and closer to the x-axis, but doesn't cross it. So what is that equation? The x-axis is actually y is equal to what number? Do you guys remember? It's actually y is equal to 0. So for each one of these, because they're all the same type of parent function, is y is equal to 0. Okay, so now let's talk about the next thing, increasing, decreasing. So this function, all three of these functions, both of them are increasing. So they're coming from the bottom, and then they just keep going up and up and up and up. So from x is negative infinity, right? So I'm coming from negative infinity on x, and my graph is going up, 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 up. So it's increasing to my x keeps going this way to positive infinity. It goes up. So for each one of these, it's the same thing. It's increasing from negative infinity to positive infinity. Okay, and the last thing that I'm going to have to move my my paper up a little bit here. Okay, but you should have your graph in front of you so I can move my stuff up. Okay, is this question down here. It says, what effect does changing the base, okay, the base means the 2, the 3, the 4, what happens when I change that? So when I had y equals 2 to the x, y equals 3 to the x, y equals 4 to the x, what happened by changing 2 to 3 to 4? And what happened was it made the graph steeper. Okay, so it makes the graph steeper. Okay, so so you can actually say the rate of change, which we'll talk about in a couple days. The rate of change is steeper. Okay, all right, so that's it, and we'll practice a lot in class over the next couple days. Okay, have a good night, everyone.